All right, all right. So the last couple of weeks we've been talking a lot about architectural visualization, and we've been discussing some tools and some techniques that are really important for that workflow. Well, today we kind of change gears a little bit. Today we start exploring a new part of the 3D industry, and we're going to be talking about the product design industry. Architectural visualization has grabbed the 3D art and 3D modeling industry, and they have run with it in a big way. You know, everyone in the ArchViz world is using computer graphics these days to illustrate the buildings, you know, whatever it is that they're making, and it's a natural pairing. Well, the other natural pairing that we run into in the 3D world is product design. So today, and this week and next week, we're going to be discussing and exploring the art of product design and how we can use the tools inside of Modo to generate a whole series of images that could be used in a commercial application. Let's jump in. I've made a little website here for you guys that just defines what we're going to be talking about over the next couple of weeks. In the overview section of this week's course page, I've given you kind of a nice little overview, a nice little written overview of the application of these tools and these technologies in the commercial world, but I think the images here speak a little bit more loudly than the text that I've written. Because ultimately, what we're going to be doing here is making a whole series of models and renders that could be used in a commercial application. In my mind, I kind of call these the high glossy renders, something that looks perfect. Okay? These are all 3D. Every single one of these are 3D. Every single one of these made in Modo, by the way. Okay? None of the images that I have on this website aren't Modo images. All 100%. Because those bottom ones, those look real. Those look darn real. And this is why product design is exploding right now. It's because the technology has gotten us to a point where we can make photorealistic renders at a reasonable price point. You know, 5 or 6 years ago, doing work like this would have cost a tremendous amount of money. The software was expensive, the hardware was pretty expensive, and the amount of labor that went into it was expensive. Well, that whole paradigm has been flipped on its head, and now it's become inexpensive to make all of these images. Okay, Modo is a pretty fantastic tool for product design. The architectural guys have flocked to Modo because it has a really strong tool set that allows us to model with accuracy. We've been going over that for the past couple of weeks. But the rendering engine inside of Modo, I think, is probably one of the strongest elements of the technology that we're using. We can make some really beautiful pictures inside of Modo quickly. Okay. Doesn't take a lot of setup, and you've probably have heard me say this in a number of other applications or a number of other conversations that we've had this semester. But if you think working in Modo is hard, start exploring other packages. It's 10,000 times more difficult than what we're working on here. So being able to set things up quickly and produce good quality renders without a lot of effort is a really big boon for the Modo crowd. Okay. Modo at the core has a physically based lighting and rendering engine. So we're in many ways simulating and working inside of an environment that's not too different from how our actual environment interprets light rays, reflections, refractions, volumetric effects. It's almost identical. Okay? So it makes it easy for traditional artists, traditional product designers to jump into this workflow and to create some very compelling images. Let me ask a question though. Why do you think product design, commercial advertisements, and 3D rendering go hand in hand? Why are art directors all around the world flocking to computer graphics to make images, to sell things? We can be extraordinarily creative, right? We're not limited by gravity. We're not physically limited by what we can pull off inside of the camera. And I think this image at the bottom beautifully illustrates this. Okay, pretty rad, huh? I love it. If we were to try to create this image practically with real fruit, real bottles, real leaves, it would be impossible, right? Well, it wouldn't be impossible, but it would require a tremendous amount of engineering. Okay? Yes, sir.
Well, fake fruit.
It would be all fake fruit, yeah, we'd have to create a whole series of support structures for the fruit to get them to stand and be placed correctly within the scene. Last time I checked, leaves don't magically stand up like that on the left-hand side of the image, right? They would fall over, right? So there'd need to be some sort of rig, some sort of physical support structure that would prop that little leaf up inside a real photographer's studio. We can do it virtually much faster, much cheaper, that's a good word, much cheaper and easier, okay? Using our virtual goods, okay? In addition, and this is kind of going back to what Alan was talking about, it had to be fake fruit, right? Yeah, I'm gonna, What you see on television, it's all smoke and mirrors. It is all a gigantic illusion. Next time you watch a commercial for, I don't know, anything, Carl's Jr., what have you, you're not looking at a real hamburger there, folks. That is not real, okay? That is fake. That's very, 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 very fake, okay? Especially McDonald's. And all food commercials, you're not looking at the actual product. Great example, ice cream. Ice cream. I see a lot of commercials for ice cream, okay? It should melt, right? If you guys have ever worked in a photographer studio, you know that the lights that we use to illuminate our subjects can get very, very warm. Last time I checked, when you put a cold substance like ice cream in front of a warm light, it's going to melt, right? And it's going to melt quickly. It's going to melt quickly. Some of these studio lights are so bright and it's so warm, you kind of feel like you're outside in the sun, okay? It's amazing how hot and warm these light rays coming out of these traditional studio lights can be. Has anyone in here been in a theatrical production on the stage? I mean, you guys know firsthand. You stand in the theater lights on the stage, and you can feel the moment you walk into the light rays because there's a tremendous amount of warmth underneath those lamps. So, in an image like this, it would require, if I was the creative director working at an ad agency for Jamba Juice, okay, I would have to go out and find a production company that are masters in creating false, fictitious food, okay? And that's an incredibly detailed art form unto itself, okay? That costs a lot of money, a tremendous amount of money. We don't necessarily get the flexibility that we're going to need to be creative all the way through the design process, right? So computer graphics gives the artists flexibility, okay? We can break the rules of gravity. We can put our elements anywhere we want within the scene, and we don't have to worry about them falling over or wilting under the light or having, putting off a weird reflection or something. We have creative control over every single pixel that shows up in the final image. Another thing that advertisers love about computer graphics is that they make everything look factory fresh, right? Perfect. It's perfect, right? The moment we start handling an object, and it doesn't matter what that object is, we're going to start to impose a certain level of humanity into that object, okay? Now, the moment we touch something, a fingerprint is going to go on that object. The moment we put it out into our environment, it's going to start to erode. Dust particles are going to fall on it. It could get scratched. It could get nicked. It could get bumped. I mean, the surface characteristics of the Coke can, for example, are such a great example of this, okay? We should be seeing little scratches and dings across the entirety of that Coke can surface, right? Yeah. That's pretty factory fresh. That's as if they took it directly from the manufacturing line at the plant, put it in some sort of sealed container while wearing white gloves, took it to the photography studio, very carefully took it out, put it at an angle, lit it carefully, and took a picture of it, right? Yeah. No, that's never going to happen out in the real world, but in the computer world, we can absolutely do an image like this and make it look perfect, 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 as if it just came off the manufacturing line. Smoke and mirrors, it's all a gigantic illusion. Here's a great example. I was watching television a while ago, it's probably a couple months ago with my wife, and a car commercial came on, a car commercial, and the opening shot of this car commercial was like a Chevy Camaro or something, and it was just roaring through the middle of a dried salt lake, right? And it was kind of a cool helicopter shot. It was way up high, and I looked at the car and I said, "That's computer graphics." And my wife was like, "Oh, come on, it's not computer. Come on, all right, smarty pants. Quantify your statement. Why is this computer graphics? Since you teach computer graphics, you think you know everything, right? Tell me why." And I was like, "Okay, let's break it down a little bit here, okay? If this was a real car hurtling through the middle of Nevada, okay, it was kicking up a gigantic plume of dust behind it, right? Gigantic plume of dust, as a car normally would. Rock and roll. But as the camera got closer to the car, there was not 1 ounce of dirt on that car, okay? In reality, what would happen? The entire back half of the car would be covered in dust. No dust on that car. Factory fresh. Perfect. It looked perfect. Advertisers love computer graphics because they can make their car look perfect on every single frame. If that was an actual car, it would look dirty and ugly, okay? Because of the dirt that was on top of the car. Yes, sir.
About car ads where it shows a car driving along a mountainside, and the cameras, and it
Could very well be. Could very well be. Car commercials are renowned for using a lot of computer graphics. A lot of computer graphics. Shoot, I would place large sums of money that 9 times out of 10, there's going to be some sort of computer-generated element in most commercials that you see on television these days. Shoot, another perfect example. How many guys have been to the Apple website? I have. Big fan of the Apple website. Every image that you see on the Apple website is computer-generated. Okay, is absolutely computer-generated. Let me show you. As it loads, computer-generated. Okay. 100% false. This is not a photograph. This is a CG render. Why? Well, I know it's computer generated because I know the guy that actually does all the artwork for the Apple website, and so I know that they're fake, and I just happen to know he uses Moto too. Awesome. Okay. All computer generated. These are not photographs. Okay. Apple is renowned for, even in their retail space, having their products look as though they're inside that clean room, right? Have you ever been into an Apple store? It's got the white walls, the white wood floors. I mean, it looks very, very sterile, right? It looks as though you're in sort of like some manufacturing fabrication environment, okay? And that's because it makes their images and it makes their products look perfect. It looks perfect, okay? So we're going to be studying this idea of making perfect-looking images. The product of this week is going to be a project that you're going to design and create, and hopefully, if you've done your job right, you will be able to produce a render that could go in a magazine, that could be used to sell this cell phone. Okay? So that's the goal here, is that we're going to be looking at the art of computer graphics through the commercial applications of computer graphics. This week, we're going to focus entirely on the workflow and the pipeline on the model side. Next week, we're going to talk about the texturing and lighting side, which brings in its own series of challenges. Okay? Now, because of the type of images we're going to be crafting, our render camera is going to get extraordinarily close to our objects. Okay? Since we're going to be seeing our object up close and up close in the view of our render camera, the model needs to be perfect. We have to have a high degree of technical accuracy across the surface of our mesh because the audience is going to see it if it's wrong. Okay? When we were working on our house, if there was a problem with the geometry of the house, if a polygon wasn't precisely where it needed to be, or maybe there was some misalignment on some of the details in the scene, no biggie, right? Because the render camera was pretty far away from the house. Small little technical errors, not that big of a deal because the audience isn't going to see them when the camera's that far away. Well, this week, our camera is going to be right up next to this bad boy. It's going to be within inches of the model. So it's imperative that the model that we create is perfect. Okay? So today we're going to be looking at some ideas that will allow us to make a perfect model. Okay? We're going to be really paying very close attention to the polygonal flow, the structure of our model. We're also going to be talking and revisiting again the idea of subdivision surface modeling. Since we're going to be right up next to these bad boys, we can't see any sort of illusion or representation of a polygon across our geometry. It needs to be perfect. Okay? Cell phones, or in this case, if you look on the screen, a water bottle, very rounded out, okay? You don't see any polygons in there. That's because it's a sub-D object, okay? This has to be a subdivision surface object. So we're going to revisit the strategies, techniques, and ideas that we're going to leverage to craft a subdivision surface object, okay? As I mentioned before, the assignment this week is a cell phone, okay? I've chosen a cell phone because almost every single one of us in here either has a cell phone, has seen a cell phone. They're everywhere in our society. I would wager a bet that probably almost everyone in here has some sort of mobile device on their person or within 3 feet of them. Okay, so it's a good assignment to use because we're very familiar with the technology and we're very familiar with the shape. It also is going to challenge you on a lot of different levels because there's some compound curves in this bad boy. Cell phones are kind of organic in their shape and in their nature. The buttons are going to prove to be a little bit of a challenge. This is going to be a difficult model. I'm not going to sugarcoat it. In many ways, this is the culminating experience of this entire hard surface modeling component of this class. This is it. This is the last project that's going to be a man-made hard surface object. After next week, after we finish out the texturing stage of our cell phone, we're moving on to organic stuff. We're moving on to characters. So this is kind of like our midterm exam, if you will. It's really not a midterm exam, but think of it like that. This is it. This is the culminating experience. This is where we get to use 10 weeks of content and 10 weeks of education in one project, okay? So what's going to challenge you? It's going to test you on a lot of levels. If you've been over in the lab, you probably have heard people talk about this project. The lab staff is probably going, oh no, it's cell phone time. We're going to get a lot of questions, a lot of confused people, and that's by design, okay? Yes, sir?
Is there a limit to what kind of phone you can make?
There isn't a limit. You're going to pick your own. However, I'm going to make some suggestions in a minute that will hopefully guide your decision-making process to the right phone, okay? So you're going to be choosing your own phone, or a phone. I'm not going to put a limit on which phone you can make. The only limit is that it can't be a touch phone. It can't be an iPhone. Yeah, no, it can't be an iPhone or a Galaxy. It's got to be a phone with buttons. Because modeling an iPhone, I mean, come on, this is like 5 minutes worth of work, right? It's just a cube with rounded corners on it. I can do this in about 10 seconds. Okay, so it needs to have buttons on it, and we'll come back to that here in a minute. Yes, sir. That's fine. That's all good. Okay. As a reminder, this is going to be a two-part project. Okay. So geometry this week, textures, materials, and rendering next week. Lada. You can. Yeah, you can, but we're going to be working with reference a lot this week. So that may be a limiting factor. I'm not against that idea, but we want to include some schematic blueprints into the mix here to make the accuracy of our model just kind of skyrocket. Okay, so I'm not opposed to it. Let's have a conversation after class and kind of see what direction you want to head in. Okay, it's going to be easier if you use the schematic blueprints. Okay. Yeah, you can use a smartphone. You know, if you look at some of the examples, I think the one over on the left is a BlackBerry or a Trio or something. It's got to have buttons. It's got to have no touch screens. It's got to have some buttons. And when I see buttons, I mean more than just like, you know, the home button on your iPhone, okay? It's got to have, you know, some old school buttons on it. Oops, just turned my phone on. Okay. All right, since this is the culminating experience of this project, I've assigned and I've developed a rubric for how you're going to be evaluated on this, okay? So I wanted to get incredibly specific here as to what I'm looking for you to accomplish inside of this project. This rubric is going to span both components, so both levels of this project, this week and next week. You can find it right below the requirements for the assignment. So these are the 4 categories that I'm going to be evaluating you on. Now there's one thing in here that's a new thing, and that's that creativity evaluation. I'm looking for you guys to impose your own kind of fingerprint on the final design. It's not just about the model, okay? It's also about the picture that you create, okay? Because at the end of the day, in every single computer graphics application, you are going to be making a picture or a movie. The model doesn't matter, okay? Well, it does matter. It's just one part of it. The other part, texturing, the rendering, and the level of creativity you're going to be imposing into the render to give us a compelling result. Next week, we're going to be talking a lot about categories 2 through 4, texturing, rendering, and creativity. And I'm going to show you some really compelling examples that will hopefully inspire you to create some really great work. Okay? More on this as we get closer to the end of the day. We'll talk about the rubric in a little bit more detail. But check it out. You're going to start seeing these on every single assignment going forward. Okay. To kind of reinforce some important technical things today, we're going to be working on a lab assignment that's going to challenge you to align a number of backdrop items to each other over in Modo. Okay, so more on this later. I think if you follow along in the first little bit here, you can probably do this lab assignment as we go through our conversation today. Okay, so more on this later. It's a fast, easy one. It's kind of fun. I've given you all the assets you need for the lab assignment in the Resources tab. There it is right there, Lab Assets Assignments. And then there are 2 links down below that I want us to focus a little bit on. Okay? We have theblueprints.com and Modopedia. Let's start with Modopedia. I know I've talked about this website in the past, but through today's conversation, I think this is going to be a nice addition to our workflow. One of the things, I'm going into the video library up here at the top. One of the things that's challenging for everyone is understanding the sequence of how to model complex objects and complex shapes. Inside the Modopedia video library, there's a projects section. And in this project section of the website, there's some really great illustrations of some complex projects. Okay? So for example, let's do that's modeling a car. So here's all the videos that describe how to model a car. This, use these videos as reference. Okay? 9 times out of 10 is the hardest part is figuring out where to start. Sometimes seeing how other people approach the modeling process can serve as a fantastic inspiration to where you find your own start. Okay? In addition, I also want to draw focus to another great series of videos on the Modopedia website. If you go to the modeling section, kind of down here towards the bottom, yeah, here we go. There's a whole series of videos on subdivision surfaces that I think would really be of benefit going forward. A lot of these concepts and ideas we've talked about in this class in the past, but everyone needs a little refresher, sometimes just to underscore an idea and to illustrate the sequence. These videos do an excellent job. I didn't make any of those videos, so you don't have to listen to me talk after. Okay. All right. If you go back to renderography, the last link that I want to talk about today is theblueprints.com. And this is actually a resource that you're going to be leveraging for your assignment this week. You guys know my mantra. You guys know my rules around here. I'm an old school modeler, and I truly believe if you're modeling without reference, you are modeling fundamentally wrong. Okay? You are doing it wrong. It's bad form. It's bad technique. So let's rewind for a second and kind of re-explore why reference is so important. What do reference images give us? They give us accuracy. They give us details. Vincent, if you get a comment? Accuracy. They give us accuracy, right? Say it. Yes, better understanding of the 3D model itself. This is a challenge for us in the 3D world, right? Taking a two-dimensional idea and extrapolating that into a three-dimensional model, okay? All of us in here think in 2D very well. We've been thinking in 2 dimensions since the moment we came out of mom, or maybe the moment we started drawing, okay? We can do things in 2D very easily, right? Using 2-dimensional reference photographs to make a 3-dimensional model is a natural fit. In addition, reference photographs, in addition to giving us accuracy and control and details, reference photographs define proportions better than any other thing out there. All of you guys in your mind right now know what a cell phone looks like. Yeah, I'm sure you guys, the moment I said we're doing a cell phone, you go, oh, sweet, I'm making my own cell phone, right? I'm making the cell phone that's in my pocket right now if it had buttons, okay? You guys know what a cell phone looks like. Make it in 3D and let's see how close you get to that image, okay? The moment you draw something or the moment you're asked to draw something or create something in 3D, that, if you're, the proportions of that object are not going to match your vision or what's actually found in reality itself, okay? It turns into a little bit of a challenge. We all think we know what a car looks like until we have to model it, and the result that we get is going to be wildly, and I mean wildly wrong. Go back to the lab assignment with the Jeep. A lot of the projects that were turned in here, and this is of no fault of your own, the proportions of certain details on that Jeep were just off. Some of your Jeeps were really skinny, some of your Jeeps were incredibly wide, some of them were long. The proportions were off. This is the hardest part in 3D, right? Figuring out the spatial relationships and the proportions of the major elements on any object. Reference photographs are going to give us those proportions. They're going to tell us how large, how wide, how long, how deep a certain detail or a certain form along our object's going to be. In addition to giving us almost kind of, a battle plan for what this object is supposed to look like, it's also going to allow us to walk through the modeling stage much faster. Because believe it or not, tracing something in 3D is a whole lot easier than having to come up with it from scratch, okay? We don't have to use our brain, our creative engine inside of our brain to figure out all the proportions. We have the instructions on screen. Now it's just a process of decoding that instruction those instructions with polygons. That's the challenge, okay? Using reference images at the core of your model is not cheating. A lot of people think that they feel uncomfortable. It's like, I feel like I'm just tracing someone else's work. No, that's how we do it. That's the technique, okay? Even when you start working with objects that are impossible to craft here on good old Mother Earth. Like, for example, I'm working on a model of the Millennium Falcon right now because I'm a super big Star Wars nerd, right? Last time I checked, not really a Millennium Falcon out there that I can go take reference photographs of, okay? I have to kind of leverage some concept drawings and a lot of production photographs of the film to get the details that I need for certain areas of my model, okay? Concept designers are gonna, hopefully, if you're working with a good one, are gonna give you some great images that will lead your decision-making process as you make a 3D version of their two-dimensional design, okay? It's just how we work. It's just how we work. You're going to be employing this technique, and you're going to be working with reference for almost every single stage of this model. The-blueprints.com is a fantastic resource that will allow you to very quickly go find schematic blueprint drawings for just about everything in the world. It's fantastic. It's the largest library online. I love it. I've been going to it for many years. If we check it out real fast, you can see that the link takes you to this really cool library. And excuse me for a moment. My shoe came untied. If I don't tie it, I will fall over and make a fool out of myself. Okay, so here we go. Here's what the website looks like. The place that we need to go is right here, the Blueprints database in this link. And you can see that they've broken their library into a whole series of subcategories. And it's pretty comprehensive. They have schematic drawings for almost everything on the web or any object out there in the real world. We have cars, planes, trains, automobiles, science fiction stuff, and of course, phones. Yay! Perfect. Okay. So let's jump over into that category of the reference library and check out what we got. So they've broken up their entire phone category by manufacturers, okay? So if you look across the entire list here, you can see everything from Apple and Acer to Samsung and, some that I've never even heard of, like Buddy Bear. What? What is Buddy Bear? What is Buddy Bear? I think it's a kid phone, yeah. Yeah. Although, I don't know if that really looks like a bear. It looks more like a gerbil, yeah, than a bear. Kind of a funny looking bear. Anyways, okay. Let's go find some phones here that will give us a little bit more detail, okay, and a little bit more information. All right. Apple, let's see, Apple, you see a whole bunch of different types in here. It's kind of cool, but you're not allowed to use any of the Apple stuff. Oops, went back too far, excuse me. Let's go over to Samsung, because Samsung has a huge library of phones that we get to find blueprints for, okay? Now, a couple things about this library that you need to know. There are two different types of images that you can find inside of this library. We have photographs, and then we have vector drawings, okay? Is anyone in here taking an illustration class, a digital illustration class? Okay, for those of you that have your hand raised, help us out. What is a vector drawing? Yeah, help us out.
It's a mathematically precise drawing.
You got it. It's a drawing or an image, an illustration, if you will, that's being drawn through a mathematical algorithm. And we interface with that mathematical algorithm through those little paths, right? That's a vector drawing. What are some of the benefits of vector drawings, by the way? Kellen? No pixels, right? It's not a pixel-based art form. So what does that mean?
Accurate scaling.
Yeah, we can make it as big or as small as we want, and it's always going to look perfect. And in essence, we can take the exact same drawing, scale it down so it fits on a business card, and then we can take that exact same drawing and scale it up so it goes on the side of a building, and it's always going to look perfect. We like vector drawings, and if you're taking traditional graphic design classes, vector drawings are at the core of basically every conversation in those classes. We have access to certain vector drawings of certain blueprints on this website. The ones that are vector drawings have this little Adobe Illustrator logo next to them, okay? The vector drawings you have to pay for, okay? Don't buy the vector drawings. Like, let me just underscore that. Do not buy the vector drawings, okay? there's nothing in here that we're doing that's really gonna be benefited from having those vector drawings. Okay, use the photographs. Use the photographs, which are the other type of file that you can see on the website. So all the ones that have the little camera icon next to it are photographs. Okay. With that said, continue looking down over to this side of our library. The ones that don't say vector, let's look at these bottom three, for example, have some important information in here that we just need to be aware of. The first column is the pixel resolution of the photograph. If possible, try to find the highest resolution photograph of this phone that you can possibly find, okay? So, and most of them are pretty good resolution. Let's see, there's one that's 500 by 1518. There's one that's 500 by 1300 pixels. So the more pixels, the more detail, and the more information you're physically going to see in that photograph, okay? In addition, the next section of this part of the website is also really, really important. Each column here represents a different orthographic viewport that this photograph is going to provide. So the F is front, T is top, R is side, or R is rear, and S is side, okay? If possible, we want to have all of these little check marks ticked in the column here, okay? We need to have at least 3. We'll get to which 3 in a minute. Let's just pick one real fast, so at the very least, we kind of have some marching orders here. There we go. C100. Sure, why not? So this is what you get when you click on the link. Now, if you look very, very carefully down over here, check it out. Original image dimension, 435 by 1125, okay? This is an important thing to kind of point out. I wasn't aware of this for some time until I really started analyzing the picture that was showing up in here. It's just at the bottom of the picture. On the one that I clicked on, it says original image dimensions, okay? Do you think that image is 435 pixels by 1125? No, this is not the full quality image. This is just the preview thumbnail, if you will, for the full quality image. If you want to download the full quality image, you have to register for a user account. It's absolutely free. I've had a user account on this website for many, 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 many years. And I've never been spammed. I've never gotten an email for them. And once you do, you're able to download the full-size image. Okay? Recommend that you do that. Recommend that you do that. Okay? All right. So find a phone in here that you want to model. However, be careful, because some phones are going to be more difficult to model than others. If I was to give you a personal recommendation as to the direction you should head on the content of your model, do the candy bar style phones, okay? Like the one that we just had on the screen. Flip phones, difficult, okay? Those are the clamshell style phones, the ones that, up like that, difficult. The candy bar sliders, the one that he has on his screen, that's a nice middle point, okay? But it may be a modeling challenge for you. What I'm trying to say here is find a phone that matches your current skill set, okay? If you're really advanced, if you know what you're doing, if you're really comfortable making objects in 3D, find a phone that is paired nicely with your skill set. If this is something that you're just banging your head against and you're still trying to learn the ropes, really try to find something here that's a little bit easier to construct, okay? It's going to take some digging. It's going to take some research, okay? It's going to take clicking on a lot of these links to see which one kind of works for you, but find one that works for you. Some other suggestions that I would give you guys. Don't try to find phones that are relatively cubic in nature, kind of blocky. The moment you start finding phones that are like super curvy and stuff is the moment your modeling challenge skyrockets, okay? Because you're going to be making a 3-dimensional version of this phone. So compound curves are always, always, always the challenge that we have to work against inside of 3D. So do some digging on here. Just don't pick the first phone that you see. Like for example, the Samsung Armani. What's that look like? That's boring. And it doesn't have any buttons on it. Yeah, and after going through this website over the last couple of years, I'm reminded of how many phones that we in the US don't even see. I mean, I've seen phones on here, I'm like, that's a cool phone. Why don't we have that here in America? Oh, wait, it's only in Japan. Got it now. All right, kind of a bummer. Yeah, there's a lot of phones on here. A lot of phones, a lot of objects. So do some research, dig around, and you'll find one that works for you. There's a lot of different brands. I know the Ericsson phone's incredibly popular. Sony Ericsson used to have some of the best phones in the business way back in the late 90s and the early 2000s. So they have a huge collection of some awesome phones in here. The Ericsson phones have historically always really been that candy bar style. So find something in here that you like. Okay, I'm going to leave it up to you to figure out whatever phone that you want to use. Okay, it's just got to have some buttons on it. So we're going old school with this bad boy. And if you really want to go old school, yeah, check this out. Someone took me literally a couple years ago, and they really went old school. I like it. Yeah, awesome. Nice. Oh, can I have it?
That's on my dad.
Ah. Well, never mind. All right. As a professional, you're going to be using this website a lot. This is usually the first place that I go whenever I start any project. If you're doing a hard surface object, a man-made object, planes, trains, and automobiles, this is the place to go. Even with organic stuff, they've actually increased the number of organic schematic blueprints they have on the website. We're going to be revisiting this humans category here in a couple of weeks as we start to explore the process of organic modeling. There's a lot of fun ones. Let's see, we can do some of these comic book characters I'm not familiar with here, but let's see here where I found go old school Marvel, Banshee. Awesome character sheets. So we're going to be working with these here in a couple weeks when we start talking about organic objects and characters. It's kind of fun. Okay, questions on theblueprints.com? Great. What I want to talk about now is how to work with these images that you're going to download from theblueprints.com. Because what you're going to get whenever you download anything from theblueprints.com is an image that contains a number of different orthographic pictures of your cell phone. I've downloaded one already for you guys. Let's see, it's somewhere on my desktop. Hold on a sec. There we go. So this is the photograph that I downloaded from theblueprints.com right before class started today. It's a Samsung C100 phone. This is the high-resolution picture that came directly from the website. Didn't change a single thing. So this is what you're going to get. However, this isn't the image, or these aren't the photographs that we want to work with over in Modo. Ideally, best case scenario is that we're going to use these photographs as backdrop items over in Modo, right? So I need to kind of isolate each one of these pictures in its own file, right? I want to have a self-contained PNG file or a JPEG of just the front, another file of just the side of our phone, and maybe another one of just the top, okay? At the very least, whatever images that you use to help model this phone, we want to use them as backdrop images so that we can accurately recreate the size, scale, and proportions of all the details across the surface of this object, okay? So we need to isolate. That's the first thing. We do not want to use this composite image 3 times on 3 different backdrop items. That's going to confuse your brain. Trust me. I've done this long enough. Isolating the images is going to make your little noggin work a whole lot more efficiently inside of this process, okay? Unfortunately, this is the stage that people blow by almost every single time, okay? You can't ignore this part of the process, okay? If you spend your time now setting up all of these backdrop items, you're going to work a whole lot faster. Trust me, the accuracy of your model is going to skyrocket. Now, I know exactly what you guys do because I used to do the exact same thing. You start a new project, you're like, sweet, I'm modeling the Millennium Falcon. And you just jump into Modo and you just start throwing down some polygons, right? Because you're excited about it. You want to start working on the actual model itself. It's very difficult for people to kind of go, whoa, hold on a second, pull back on the reins, let's slow down. Let's create the foundation of our model first with reference images. Then when we're ready to go onto the modeling stage, we know exactly where all these polygons need to be placed within inside of our scene. Okay? So the first thing that we got to do is set up our backdrop images. And before we even open up Modo, as I mentioned, we have to isolate these images into their own dedicated file. Now here on the Mac, Really easy to do this, extraordinarily easy to do this. If you're a PC user, you're on your own, because I haven't touched a PC in probably literally about 10 years, okay? So I don't know what's natively built into the operating system that will allow you to do this. On the Mac, our default image viewer is called Preview. And Preview comes with a number of really great image editing tools that will allow us to separate out all of this content quickly, and that's the idea, okay? So I'm going to use Preview here to generate 3 separate files from this master composite, okay? Let me show you how it works. It's really quite easy to work with. Right, here we go. So the default tool, whenever you open up Preview, the tool that's always active is the marquee selection tool. Now, if you're used to working in Photoshop or have a little experience in Photoshop, this idea of selections is probably second nature to you by now. What we're doing with this box is that we're basically defining an area within the image that we want to edit and we want to control. We're isolating the pixels within inside the selection box to be edited. So I'm going to go in and just very carefully select an area around our cell phone, and just going to see if I can get it kind of close here. I don't need it to be too close. The moment you start doing like this, it gets dangerous. Give yourself a nice little border around your image. It's okay that that little blue triangle's in there, because obviously I'm not going to build that. Okay. Now from that selection, check it out. This is how easy it is on the Mac to switch this all out. We just go to Edit, and we're going to copy the pixels that are inside that selection box. Now, if we go up to the File menu, the first option is New File from Clipboard. So it's going to take all the pixels that we just copied and create a new file from them. There it is. Now we just have to save it. Notice that the file name is untitled. So we File, Save. Let's give it a good name and destination. I'm just going to save these on my desktop. This is going to be phone front. I like the PNG file format. It's my fave. Don't need the alpha channel, so I'll just click it off. All right. Let's do it a couple more times. Let's just grab the side here. Edit, copy, file, new from PNG. PNG is a great file format for a couple different reasons. It's small. The file size is relatively small in comparison to other file types out there. It's also almost uncompressed, so it doesn't really change the quality of the image, which is good. JPEGs, heavily, heavily compressed. You destroy your image, basically, on a pixel quality level when you save it into a JPEG. PNGs, almost no compression, so you're preserving almost like 100% of the quality in the PNG. In addition, it's also an open source file format. Okay? No one owns the technology that's generating and driving that image format. JPEG is owned by CompuServe. Okay? Oh, excuse me. GIFs are owned by CompuServe. No likey the GIFs. Okay? There is a media conglomerate that owns the JPEG file type. Okay? This is an issue because let's say you're working at Blizzard. Okay? Blizzard are the guys that make World of Warcraft. And maybe all of their files, all of the texture files that are physically being applied to the game characters are saved in that JPEG file format. Well, the media conglomerate that owns the technology that generates that file type can walk up to Blizzard and say, sweet, you now owe me a royalty because you're using my technology in the JPEG file format in your multi-billion-dollar game. PNGs are open source. They're not owned by anyone. So no one can generate any sort of claim to your image. Kind of a silly thing about our world, but it actually does play a factor.
So that means like 90% of the pictures on the internet are owned by one company?
Or they have rights to that image. Okay? Yeah. Is that media conglomerate going to start charging people? They could. They could. Are they going to? Probably not. Probably not. Chances are very, very, very slim. In my opinion, like 0.001% chance that they're ever going to claim some sort of royalty on that image. Really what they're doing is they're hedging their bets, right? It's like they're hedging their bets. So, if let's say that there's one image that is sold for like $1 bazillion, okay, then they'll step in and say, hey, now we're talking some real money here because you sold the image that our technology helped generate. Now maybe throw us some cash, okay? For like 99.9999998% of the world, not going to happen, okay? I call it the Facebook effect, right? You know, a lot of folks don't realize this, but when you make anything at school, it doesn't matter if it's an English paper, you know, a chemistry project, a piece of art in our class. If you use campus technology, campus software, and campus resources, or with campus resources, guess what? That image actually belongs to the school, okay? It belongs to the school. Everything that you've done in here is not yours. It's mine. Well, actually, it's not even mine. It's the school's, okay? And the reason, and every school is like this. Every school on the face of the planet does this. And really, what they're trying to establish is they're hedging their bets. Let's say one of you guys invent the next Facebook that goes on to be sold for, you know, billions and billions of dollars, right? Then the school is going to go, hey, wait a minute. Actually, you used our computers to write the code for that. You're gonna give us some money, okay? Yeah. Huh? No, they're never going to get all of it, but they have the option to step in and say, hey, actually, you know, you use, and I tell people, don't make the next Facebook on these machines. Don't make the next billion-dollar game on these machines. If you have an awesome idea that you want to sell commercially, don't do it on these machines with our software and our community and in our buildings, because technically the school owns your thoughts, your products, everything that you do in class. Yeah. It is. It's kind of creepy, but that's just the way. It's just the way it works. If you read the fine print of your student contract, it's in there, by the way. Yeah.
I mean, mostly what they use it for is just like promotion of the school.
They do, and like I said, for 99.9999998% of the time, not a problem. Not a problem. Yeah, and you're right. And most of the time, it is promotion of the school. That's what we get as a school. You guys make a whole series of really cool artwork, okay? And since it's, you know, technically belongs to the school can put it on their website. We can put it in our newsletters. We can do whatever we want with it because technically the school owns that image, okay? And of course, the school always gives credit to the author itself. We're not going to, you know, completely screw you guys out of the credit of your work. Okay. Anyways, we've gone on a big tangent that I wasn't expecting to go on, so I apologize. Let's get back to work, shall we? All right. So I've saved out the front. Saved out the side. Let's just save this one real fast. Now do yourself a favor. I don't want to duplicate. Do yourself a favor. Come on, little Mac. Oh my gosh. My Mac is going very slow today.
Have you noticed that on Mavericks?
I'm not on Mavericks. Yeah, this is Mountain Lion. But I have on some applications I have noticed that on Mavericks. All right. Do yourself a favor when you're naming these. Be very, very specific. Don't just name them phone 1, phone 2, phone 3. Now notice that I'm not putting left or right because I really don't know yet what side of the phone this is. By putting it to side, just gives us options. All right. And last but not least, let's see. This is the top. Okay. Now you're more than welcome to import in all 6 of these. You know, most of the photographs that you're going to find on the blueprints.com are going to come with a 6-picture composite like you see here. You're more than welcome to separate all 6 out into their own. I'm just going to use 3 just to make it a little bit easier to visualize and communicate, aligning these to each other. When I have a lot of different photographs in there, it's confusing for you guys to see what I'm working with here. For all images or for all models, we need to have at least 2 reference images to define the proportions of that guy. Okay. Say again? You had a problem downloading it?
Downloading more than one. Is there a trick to downloading more than one backdrop image?
To download off the website? In Modo. No, we're not downloading anything in Modo. We're inserting the backdrop images.
Right.
Yeah.
My thing was just the way I was doing it.
Yeah.
I could transport one.
Uh-huh.
But I couldn't have 2.
Okay, well let's walk through the process of creating these backdrop images and really start to define the workflow that we need to employ to get things into Modo and get them aligned to each other. Now this is the hard part, okay? This is the foundation that we have to set. If you skip this process, you're going to be caught in a catch-22 cycle on your model, okay? Because none of these images are going to align or are going to be aligned to each other. So let's align them initially, get everything dialed, and then we can start modeling. Okay. So let's create some backdrop images. How do I create a backdrop image? Add item. You got it. So add item, and then there it is. It's the second one from the top, backdrop item. And there it is. Now, how would you define what a backdrop image is? What is it? Yeah, I like it. It's a wallpaper. Okay, good. Is it going to be rendered?
No.
No, it's invisible. So we're never going to see it in the final frame. When do we use backdrop items, or how do we use them? Reference point to model to, right? So they're really defined, or they're really designed to be something that we model to. So they're really only applicable, well, not only applicable, but they're most applicable during the modeling stage of any project. When we create a backdrop item, this is what it looks like. If we examine the Properties tab, let's just zoom in, take a look-see at it. Whoops. Let me select it real fast. Excuse me. My computer, there we go. All right, so here's our backdrop tab, okay? And of course, inside the backdrop kind of section here, we have the transform section, and then we have the backdrop section. We have an image well. We click on it. This is what we're going to get. Oops, excuse me. Then what do? Add clip. Load image. And now we're traveling to the location that these backdrop items are stored. And mine's just sitting on my desktop. So we'll do front. There it is. Ha-ha. Now let's be good stewards of our scene here. I see people doing this all the time over in the lab, and I can't recommend doing this enough. Name your backdrop items, okay? It's such an easy thing, but people overlook it because you just want to get to modeling. If you do this initially, trust me, you'll save some frustration later on. And I always do this, phone, front, okay? So I'm defining what the backdrop item is responsible to describe and which perspective it's capturing too. All right, so there's one, okay? There's one, love it. Let's start working on the others. Now, we're going to have 3 different backdrop items all inserted into this one scene. So we need to kind of employ a new technique here when working with these backdrop items. In addition to getting all of these backdrop items into my 3-dimensional scene and orientated in the correct direction, it's imperative, and I mean absolutely imperative, that all of the photos are scaled to each other, okay? Let me show you the technique that I've been using for years. It's kind of bulletproof. It works almost every single time for me, exceptions here or there, but it's a good foundation for us to stand on as we go into this high detail, high accuracy stage of product design modeling, okay? What we're going to generate, or what we need to kind of classify and define, is a master image, okay? Master image. For me, 9 times out of 10, the front perspective of my object is going to be the master image, okay? So that one right there is my master. We're going to move, rotate, and scale, or move or rotate or scale the master image to the grid, okay? And extensively what we're doing is that we are aligning the master image to the origin of our scene. This is the only time we're going to do it. And then once we do it, we don't touch this photograph again. Okay, let's do it real fast. Let's align this image to the grid. Currently, the projection type of this backdrop item is set to front. So if I change my OpenGL viewport to view the front orthographic perspective, bam, there it is. Okay, we see our picture. If I was to change my orthographic view to like right or left, would I see this image? No, okay? We're only going to see the image in the projection type that we've assigned it to, so the front. Now, I want to be able to see the grid here, but my backdrop item is kind of occluding any sort of illusion that the grid is being created in the scene, okay? How do I change this? What can I do? I want to see the grid. I want to see through this image to the grid behind it. Yeah, change the transparency. So if we go back into our backdrop properties, let's select it again. Phone front, backdrop, the backdrop tab. Every once in a while, and this is kind of a Moto thing, and it's kind of frustrating, and so I hear you. Every once in a while, you'll select an item, and it just automatically chooses the User Channels tab. Boo. So backdrop, it's kind of frustrating. But inside of our backdrop properties, check it out. We have a transparency value that will change the opacity of this item. Let's put it up to around 70%. Now we can see that it's ghosted ever so slightly. And most importantly, we can see the grid in the background. Okay? That's what we're after. We want the grid. Now we need to do some really honest detective work and begin looking at the details of the picture and how those details of the picture relate to our scene. So everyone just stare at my photograph for a second, okay? Is this cell phone symmetrical? Yes, it is symmetrical along one axis, right? The left side of the phone in the picture is identical to the right side of the phone. Well, really the base is symmetrical, right? Obviously the buttons, their numbers are different, but their shape is identical, okay? Which button? The volume control. Oh, those little rockers? Yeah, absolutely. So some of the details that are like the rocker on the left, obviously you're right, John, it's not there on the right. I'd say 90% of the base is symmetrical though, okay? So with that said, where should I position this element within our three-dimensional scene?
Yes.
A little bit to the left.
Okay, a little bit to the left, absolutely. Okay, why?
Centered along the y-axis.
Yes, absolutely. We want to have this reference photo centered along the x-axis. Sorry, Quinn, but you're right. It's left and right. Left and right. Centered along the x-axis so that when we create this shape, we can use the origin action center at our disposal. Or we can take it one step further, and maybe we only make half of the model and then mirror it like we did with the roofs of our house a couple weeks ago and have the other side automatically be generated for us. I like that idea. I'm all about doing half the work, okay? That's a great idea. So we had to look for these small little position details within the backdrop item before we start before we start modeling it. So how do we do this? How do I move this backdrop item? How do I move it? Yeah, just make sure you're in item mode, have your backdrop item selected, and then we can simply employ the move tool, the W key. There we go, and then we're just going to move it over. So I'm doing the one thing that I hate to do, but it kind of works in this particular situation. I am, for a lack of a better, I am eyeballing it. So sometimes you can't avoid it, but however, we can certainly look at specific details on the object itself and kind of extrapolate how the product designer who designed this phone was approaching the construction of this object. Okay? A little speaker up there has a little important detail that my eyeball went immediately to. That little speaker opening there looks symmetrical. The left side looks identical to the right side. And there's an opening in between those two little black cubes at the top. Specifically what I'm looking at are these guys in here. Woo, okay? So with the move tool active, excuse me, I can maybe just kind of dial it in a little bit. Now I'm using the channel box on the tool options to kind of dial it in somewhere right around and there, and that's close enough for me. It really is. It's close enough for government work. Okay. All right. And that's pretty good. That's pretty good. Okay. I don't know. It's really hard to tell just from the photograph if there's any sort of discerning feature of the photograph that defines the middle point height-wise on the phone. So I'm going to model it as is. Okay. This is a good start for me. All right. So we've aligned the master photograph to the grid. Now we're done with this bad boy. We're not going to touch it again. This is locked in your mind. If you want, you can actually make it locked, but that actually causes problems later on down the line. Okay? Do not touch this photograph again. Okay? It is not a player anymore. Okay? Just leave it alone. Leave it alone. Because if we touch this photograph again, we're going to get into this endless catch-22 edit loop, okay? When we start aligning the other photographs to the scene, okay? Because we have two more backdrop items that we have to import in. The backdrop item that defines the side of the phone and the backdrop item that gives us the information on the top. Those two backdrop items are going to be aligned not to our scene, but to this guy, okay? We're going to align them to the photograph. Let's do it real fast. Let's jump in. Let's have those other two backdrop items jump in. Let's create them. I want to zip back over into my orthographic viewport. Do add item, backdrop item. Let's give it a good name before we go any further. This is phone side. All right. If we select that backdrop item and click on its backdrop properties tab, we can load in an image using the identical same process that we were working with before. There we go. Aha! So there it is. They're both chilling and sharing the exact same space within inside of my three-dimensional scene. What do I have to do to this backdrop item to get it orientated the correct way?
Change the projection plane to side.
You got it. We have to change the projection type. Do not rotate this plane. The first thing that we want to play with is that projection type. The guys down at Luxology are pretty smart. They understand the modeling workflow. They've designed a feature into the system that will automatically change the orientation of this backdrop item based on its projection type. Okay? So let's see. I have it selected. I'm in the Properties tab. I go to the Backdrop Options. And now I'm going to work with this projection type. Okay? So the default projection type is front. Every time you make a new backdrop item, it's going to be set to front. Which projection type do we want? Left or right? I don't know which one's the left or the right, so we're going to have to do some investigation to figure out which one. Let's just do right. Okay? And you can see that the computer has all automatically orientated the phone where it needs to be in the scene. All right. Let's jump over to the right orthographic viewport and take a look at our work. Because there's a couple other things in here that we need to define before we go any further. So this is kind of like step 3, if you will, on the new backdrop image. It's imperative, it's absolutely imperative that our phone in every orthographic viewport be facing the exact same direction in the scene. Okay? If you were talking to someone in your life and describing to them the roles of each one of our three-dimensional axes, how would you describe the role of the y-axis? What does it define? Top and bottom, or up and down. Inversely, how would you define the role of the x-axis? Left and right, and then last but not least, the z? Forwards and backwards, okay? I bring focus to this idea because the z-axis plays a really important role during the setup of all of our backdrop images. The z-axis defines the front of our scene, right? Front in finger quotes, okay? We want all of our images to be facing the front of our scene. Which direction is the front of our scene? Positive z. Now, just based on the information that you can see on the screen, which direction is positive z? The left. How do we know that? You got it? So if you look very, very carefully, there's a faint grid indicator right there. Let's zoom in on it. And you can see it says positive z right there. So this direction, going to the left, is positive z. In addition, if you also look at the orientation of the compass in the bottom left-hand portion of your OpenGL viewport, it also tells you the orientation of all of the axes. Okay? The direction this line and this area or this letter is facing is the positive direction of that axis. So which direction is the positive y? Up, right? Because that's what my compass is telling me, that all the positive y values are at the top of the scene, or top of the screen. So basically what I need to do is ensure that the front of my phone in the picture is facing the front of our scene. Let's zoom out and look at what we have. Is the front of our phone facing the front of our scene? Thumbs up? Yeah, thumbs up. It is. It is. And we know this by looking at the photograph. What area of the photograph represents the front or the face of the phone? The silver part, that's where all the buttons are. And if you look very, very carefully, you can actually see some of the buttons poking through on the front of the phone. So there's kind of what I'm going to call the home button on the phone. And these are where all the numbers are in here. So that detail in the photograph is facing positive Z. Aha! So now we have in the front backdrop item, it's facing positive Z. The side photograph is facing positive Z. So we're starting to align these pictures to each other now. Let's go ahead and bring the top guy in, that third backdrop item. Same process, add item, backdrop item. Let's give it a good name. Phone, phoner, no, phone, top. There we go. Let's go into its backdrop tab and load in the image. Phone top, okay. And let's change its projection type to top. If we look at our scene in perspective, you can see where our phone is. Let's look at our scene from the top and make some corrections to our top reference photograph. Okay. Based on the orientation of the picture in our scene, what do we have to do to this picture? Eli, flip it. Why do you say that? Yeah, the silver side of the picture is facing negative Z, right? Here's our compass indicator. Our compass indicator is telling us where the front of the scene is. Right now, our picture is facing the wrong way. What are we to do? Flip it. Okay. Let's select the backdrop item that we need to edit. Go to the backdrop tab, and then check it out. We have an option over here called flip. Boom. Well, that didn't work. That didn't flip it. Flip it the right way. Flip it the way we wanted to. Flip, 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 flip. It's just taking this detail and popping it over here. Say again? So we can invert it. That's inverting the colors. Yusra? So we can rotate it. Rotate it. In certain situations, the flip command is not going to give you the type of orientation that you need in the scene. Okay? We very rarely want to physically rotate our backdrop items. This is one of those situations where we have to do it. Flip isn't working, so now we have to manually go in and rotate this bad boy 180 degrees. So notice that I still have my item selection set active. The backdrop item is selected in the scene. So if I just grab the rotate tool, I can just rotate this guy -180. Ah, now we're good to go. Now we're good to go. Okay? All right. Yes, sir. Yeah, I think we're good. I think we're good. All right. So things are looking pretty nice here, but we're not done yet. We still have a little bit of work. Okay? We've imported all these backdrop items in, but we have no idea if they're in the correct scale to each other. Okay? The only way to test this is to make some geometry. We have to ensure that all the photographs are in the correct proportions to each other. You see this all the time with reference photographs. We have a gigantic photograph of like the side of your car, and then you import in like the front blueprint and it's super tiny, right? We need to scale and position these reference images to each other. We've been doing it to the scene, to the three-dimensional grid. Now we got to do them to each other. Are we going to touch the front one? No. Master. Locked. Not going to touch it. However, we do need to use the front to define some features. When you're working through the alignment stage of your getting your backdrop styled, you need to find a couple features. Okay? These features need to be seen in at least 2 photographs. Okay? So for example, we're going to start with the front, and then we're going to go to the side. What part of the front can we see in the side photograph? Let's go to the front. What part of this photograph will we be able to see if we were looking at this phone in the side picture? Which button? Okay, that's a pretty small detail. Think larger. Color difference? Yeah, kinda.
The lines for the top and the bottom?
There it is. We can definitely see the top of the phone from the side, and we can see the bottom of the phone clearly from that side photograph. Let's prototype this. Let's check it out. So here's the front photograph. I can very easily see the top, very easily see the bottom. If I was to change my OpenGL viewport to look at our scene from the right, there's the top, there's the bottom. So that's a good feature that we can use to align these photographs to each other. So here's what we're going to do. We're going to jump back over into the front view, and we're going to lay down some geometry, some planes. They're only going to be used to help us align these images to each other. So I'm just going to use the cube tool and just draw out a silly little plane. Now I need to position this plane precisely where I want it to go. Let's see. I'm going to use the bottom edge of this plane to define the location of the top of the phone. So that's something I'm going to remember. This edge, that bottom edge, defines the top of the phone. I need two of these. Let's copy it. I'll do edit, copy, edit, paste, fire off the move tool, and drag down the copy of my little cube. So exciting. The construction workers are banging loudly because of my awesomeness. That's close right about there. Okay. So now the top edge of this bottom cube represents the location of the bottom of the phone. Let's zip over into 3D, and I need true three-dimensional geometry to do this. So I'm just going to extrude these reference planes along the z-axis, make them nice and long, and then let's just move them forward so they're... Huh?
Am I just at a weird angle, or is your top edge not perpendicular?
My top edge.
Top edge that you just created. See how it's cockeyed?
Is it?
Might be the angle.
Might just be the angle, yeah. Yeah, it looks pretty good for me. Okay, so here is the side orthographic viewport. We're looking at our scene from the right. Remember, the bottom edge of the top cube, so this guy right here, bottom edge of the top cube represents the top of the phone in the front image. Then this guy down at the bottom represents the bottom of the phone in the front image. With that said, what do I need to do to this photograph? Got to make it bigger so that the top of the phone in the side photograph matches that reference geometry. We're using these reference planes as kind of markers as to where certain features in the photograph exist. So let me go grab that item, the backdrop item. Just going to select it and just make it bigger, just using the scale tool. So I'll probably need to do a little bit of scale and a little bit of moving around here, just to try to get it somewhere kind of in there. Yeah, I'm close. Yeah, I'm going to be really, really close here. And I'm going to be a little bit anal retentive. It's kind of a little dancing, and it's made more difficult by me because I'm using a pen tablet. I think I went a little too far there. Yeah, there we go. That's pretty good. I'm happy with that. I'm happy with that. Now I know just visually that the top of each one of these photographs, the top of the phone in each one of these photographs is in the same place. And the bottom of each of the phone in each one of these photographs is in the same place. Okay, so we have the side photograph done. Now we need to do the top. We're going to go back to the master image. Every time we do a new backdrop item, we return to the master and do some analysis. What we're looking for here is more features that we can see in both the front and the top. Let's just do it real fast. Let's go back to the front. Okay. Now, what features of the phone can we see in the front picture that we can also see in the top picture? The sides of our phone. Let's do it real fast. I'm just gonna recycle this reference geometry. I'm just gonna rotate it 90 degrees. All right, and let's get this dialed where we need it to go. Let's just move it into position. So I want to move this so that it kind of defines that left edge, and this one I want to move into position so that it defines the right edge of the phone. Okay, cool. Let's go look at our scene from the top, okay? Based on the information that you can see on the screen here, what do I need to do to the top photograph? This represents the left side of the phone. That edge represents the right side of the phone. What do I need to do to the top photograph? Make it bigger. Let's just scale it up. This one's really got to go big. Oops, the rotate tool, excuse me. A little bit more perhaps. There we go. That's good enough. There it is. All right, awesome. Let's test it. We're not done yet. We've aligned all these pictures to each other, but we need to test our alignment. I'm done with these reference planes. Their job is just to help me out a little bit. Excuse me, hit the wrong delete button. All right. While we're here, let's make these other backdrop items just transparent. It'll make the next stage a little bit easier to see what's going on. There we go. All right. Now that we have all these images aligned to each other, it's imperative that we test the alignment before we go any further. I'm going to define this shape with a cube. I'm not paying really close attention to the details yet. I'm just trying to define the overall volume, the rough overall volume that this shape dominates. Okay. All right. So I got my tool still active. So if I change over to the right perspective, I can continue modeling. All right. Aha. This is good. This is very good. Okay. Because now in both photographs, the tops and the bottoms are generally matching. If I was to drop the tool and look at my object from the top, yeah, the cube from the top generally matches the photograph. I can make a couple small little tweaks here to give us the alignment that we need, but overall, it's working quite beautifully. Yeah, not bad at all. Not bad at all. I am in the ballpark, as they say. I'm going to just move this backdrop item back ever so slightly so that it roughly matches the placement of the cube. Yeah, and that's looking really great. I'm very pleased with this. Very pleased with this. Okay, let's zip over into perspective and look at a challenge. We have a little bit of a challenge. We have a little bit of a workflow kind of killer in here. We have our model, our cube, residing at the origin of our scene. Well, what else is at the origin of our scene? All those reference images, right? Those backdrop items. Can we see those reference images? No. Can we see our model very clearly? No. It's kind of visual noise. We need to move those reference images away from the origin. But wait! We just can't do it willy-nilly because we just spent a tremendous amount of time and effort aligning them to each other. We can't screw up all that work. We have to be very, very careful. Hide them. Workflow killer. Because now we're having to always go over to the item list and click on 3 visibility icons, right? Workflow killer. I don't want to have to go do that. I need to push all of these reference images away from the origin. But I have to be careful because I can't screw up all the work that I just finished. Okay? Let me show you a great trick. Understanding which direction to push all these reference images away can be a little confusing, but Modo does a really great job of telling us where or what axes we can edit these objects along without messing up their alignment. Check it out. I'm going to start with the front image. So let's travel over to the front orthographic perspective. There it is. All right. Now, if you look very carefully, in the front orthographic perspective, we've spent a lot of time moving this element which directions? Yeah. Left, right, and then we also maybe moved it up and down a little bit. Which axes did we not move this element? The Z, okay? So we know if we move this element along the Z, we're not going to screw up its placement and its alignment along the 2 axes that we really spent a lot of time on. So here's my kind of trick. If you want to push these reference images away from the origin, go into each orthographic view. I'm in the front, and look at your compass. Whatever axis is not illustrated in the compass is the axis that you can move this element without having to worry that you're messing things up. So what axis is not visible in our compass? The Z, the blue one, okay, the blue one. So if I go back into perspective and move my reference element along the Z, only along the Z, I haven't screwed up its alignment. Let's prove it. Let's go back into front. If my cube is still in the exact same place, and it is, so if you look at my cube in relationship to the photograph, still in the exact same location, rock and roll. We haven't screwed anything up. Now it's just a process of going through every single orthographic perspective, figuring out which axes we can move this image along without messing up its orientation, and moving the backdrop item accordingly. Let's do it real fast. Let's jump over into the side, the right orthographic perspective. There we go. Which axis isn't represented in our compass? The X. So I'm free to move the backdrop item along that direction inside of our scene. Let's jump over into perspective. I'm going to grab in item mode. I'm just going to grab my side. There we go. There it is. And then we'll just move it along the X, which is the red arrow. That way. Let's go back into our scene here, or our model. Yep, everything's still aligned to each other. Rock and roll. Perfect. We haven't screwed anything up. I want to let you guess what direction we can move the top. Up and down. You got it. Let's grab the top in item mode. There we go. Let's just move it along the y-axis. We haven't screwed anything up. What we're doing here is that we're clearing out the origin from the visual noise that's going to stop our brain from decoding the model that we've just crafted. We're making it a little bit easier for our brain to understand the shapes, the polygonal flows, the edge spans, and what have you of our object. And at the same time, we haven't also messed up any of the alignment work that we just completed. This is going to be a big, big workflow modifier for you guys, okay? It's all about getting through the modeling stage as efficiently as we can. This is one suggestion that I would absolutely encourage you guys to employ in your own project, okay? Questions? Now we're ready to model. All that work just to get ready. Let's take a break. Okay, so let's just jump back in and start talking about this model. Now, I'm a big fan of defining basic shapes early in the process of modeling any object in 3D. So as you can see here, I still have that original alignment cube that I crafted in the last sequence, the backdrop alignment sequence. Okay. Well, it's a pretty good little chunk of geometry there. I can use that as the foundation for my mesh. Now, the way we want to approach this is to start with a very basic shape, a cube, and then define the overall shape of the phone first. I'm not going to focus on the buttons first, right? What am I going to focus on?
The form of the phone.
Yeah, the form of the phone, the base of the phone, okay? Don't care about where the screen's going to go. Don't care about the buttons. I don't care about the rocker arms, the volume, the headphone port on the top. I just care about defining the overall shape. So let's do some deconstruction here. Let's look at the shape and become a master of this form before we ever even start throwing down some additional edge loops and start expanding the detail of our little cube here. So let's look at what we have going on. There's some important details that I need to define with some geometry. And I'm going to use my little highlighter here to kind of help out. Okay. All right. So check it out. I'm really concerned with all of this stuff down here at the bottom. This curve is something that I need to define. Okay. That's an important chunk of this project, okay, of this phone. But also, check it out. If I was to draw a straight line from this corner, you can see that right about here, almost kind of even with the top of this inset for the screen of the phone, it tapers. It changes its angle. It's not a perfect cube as it runs vertically along this phone. And then there's another radius in here that I need to define. Okay? That's what the overall phone looks like from the front. Okay? Important details to kind of zero in on before we start modeling this thing. Now, I want to make a suggestion. This is going to help your creative brain figure out this entire process. Because 9 times out of 10, the hardest part about modeling is understanding what the first step is going to be. Here's what I do, and I do this almost on every single project that I ever model. I go grab a reference image and I print it out. Or I bring it into Photoshop, or I just turn on my little highlighter app and I start drawing on top of it. The lines that I start drawing are eventually, in my brain, going to lead to where I need to have edges to define this shape. Overdrawing, drawing on top of this, just kind of gets my brain decoding and deconstructing what the shape needs to look like in order for me to recreate it. We're kind of almost making our own little blueprint, if you will, of the polygonal structure of this phone. I try to keep it easy. You can do this in whatever app. Shoot, I'd even do it a lot on just scraps of paper that I have lying around in my office. If you ever walk into my office and look at my work area, you definitely know the times that I've been spending a lot of modeling because there are little pieces of scratch paper with wireframe structures all over them. Because the easiest way for me to decode what the shape is going to be is to draw the wireframe structure. I'm kind of like pre-baking or preheating my modeling oven, if you will. I'm getting ready to model by breaking down the shapes into polygonal structures. With that said, let's take it one step further. I'm going to model half the phone. So really, my brain is only going to focus on, on this side of the model. Don't really care so much about all of this jazz, okay? So let's break down some of the areas in here that I need to define. Let's start with the easy one first, the places that we have plane changes. Anytime we have a big plane change, a big angle change like we have here, we're going to have a vertice kind of right around in there so that we have an edge that can zip across the model like that. Okay? So that's an easy one. Let's kind of tackle this top here. In order for me to generate a curve at the top, well, I'm going to need to have maybe a few vertices right in here that I can push and pull around to create the shape that I'm after. And of course, whenever we have a vertice, they need to run the full length of the phone, something like that. And then I'll probably need a couple more vertices in the corners here to define that radius. Okay? Now, I'm just brainstorming here. I really don't know a lot about the shape other than what you see on the screen. Now, we also have a radius down here at the bottom. But check it out. Since I added a vertice up here at the top, with the corresponding edge loop that ran the full height of the phone, I also have maybe a vert down here at the bottom that I can use to shape that radius. Rock and roll, happy accident. I got a gift there from the modeling gods. I already have some geometry at the bottom that I can use to define that shape. We don't always need to add new geometry. Sometimes we just need to add or edit the geometry that's already there. Pretty cool. All right, I'm going to clear this out. And I want to just talk for a second about the bottom of the phone here. The bottom of this phone is going to give me a unique challenge that I have to overcome. Specifically, this radius down here. It's pretty big, and I need to define it. I need to define it with some edges and some vertices. Okay, this is going to be a subdivision surface model. So I need to think about where I can place some edges to establish other pieces of geometry. Okay, being a good modeler is being like a good chess player. We have to think 8 or 9 steps ahead, because the structures that we create here on step 1 is going to determine what we're able to do on steps 8 or 9. Okay? On steps 8 or 9, I'm going to need to be able to define this side of the screen, and then this side of the opening that's eventually going to determine where all the buttons are going to go. And if you look carefully, it's kind of a little bit of an inset here. There's a light gray area at the bottom of my reference photo that's telling me that there's kind of some sort of angled plane there. But that angled plane terminates kind of right in here, like that. That right there looks like a channel of polygons that I need to define. Okay, so I can even go something like that. All right, so there should be some geometry in here, some polygons. Okay. And I'm just arbitrarily putting these here just to kind of illustrate where polygons need to go. Now, whenever we're faced with drawing a curve, a radius like this, we have to be very aware of the polygonal structure of our phone. A lot of folks, what they try to do is that they try to have all of the edges that define the detail of the face of the phone terminate at the bottom. Well, when we're working with a curve down here, we need to have a miter, kind of like that. Okay, instead of having a structure that looks like a cube, okay, imagine these two lines represent this area, and it goes across, and then like this, okay? Instead of that, what we want to have is something that looks like this. An angle. And that angle is going to determine and help define the curvature of the bottom of the phone. Okay? Whenever we see a curve, we need to define that curve with polygons. Okay? So these mitered corners go a long, long way to help defining those curves. Okay? So structures like this, okay, where it terminates into square corners, does that look like the bottom of our phone, this structure here? No, it doesn't. It looks like a 90-degree wall, okay? Our phone's curved, so we need to define that curve, okay? A couple weeks ago when we were working with subdivision surfaces, I mentioned, I think, ad nauseum, that we can't rely entirely along the subdivision surface algorithm to define the shape. Even in its unsubdivided state, we should see all of the details on the phone. Hitting the tab key is just going to smooth out all of those details, okay? Hitting the tab key shouldn't create the shape, it should only smooth out the shape, okay? Things to consider as we're walking through this modeling stage, okay? Overdrawing, as I've just done, kind of gets your brain into the, the process of modeling a little bit, okay? It gets the juices flowing. You can start seeing the structures unfold in front of you by the lines that you draw. This also is an excellent way to experiment, to test out where you potentially could put edges and define the shapes of your phone, okay, or any object for that matter. It's a whole lot easier to erase something on your piece of paper than it is to remove some structure in the polygonal objects that you're crafting inside of Modo, okay? Conceptualizing or brainstorming. It's like digital jazz, man. We're just trying to figure out where all these polygons need to go, okay? You're going to find during the production of this phone and with most complex objects that you're going to build this thing 4 or 5 times. It's going to happen. It's going to happen. It's going to happen. I have a lot of experience in 3D modeling, but I don't know everything. I don't have a crystal ball. A lot of times when I'm generating an object for the first shape, I'm not aware of some of the pitfalls that have yet to be discovered in the modeling stage. So even people like me with a lot of modeling experience tend to build things 3 or 4 times. Okay, it's just part of the process that we go into. We're always going to stumble upon a new idea, a problem, a technical glitch that's going to influence the production of this model. Okay, so be open to the idea of doing this 3 or 4 times. It's going to happen. It's going to happen. I know. I'm sorry. It's not the news that everyone wants to hear. You never get it right you never get it right the first time. X never marks the spot, okay? You're never ever going to get it right the first time, myself included in this, okay? Perfect example, I teach a Tuesday section of this exact same class out of Davis. And I was working on this phone. It was this exact same illustration, and I started modeling it. And at the beginning of the week, I just picked this example randomly off of the blueprints.com. I just like, oh, that's a cool phone. Let's just do this one in class, right? And in front of the class, I started modeling something, and I was going, and then I hit a brick wall, and I was like, crap. I didn't expect that, okay? Time to start over, and I did. I started over right in front of the class. With that information, I was able to lay the foundation of that problem earlier on so that when I got to that problem, it didn't exist, okay? The problem came with the side image. And establishing the taper, the correct polygonal flow to establish the roundness of the phone along the side. And one of the techniques that I employed was causing some cross polygons, okay? So I basically deleted the entire phone and I started over from scratch, okay? It's going to happen. It's going to happen, okay? Be open to that. Be open to this process, okay? The folks that kind of, that don't do well on this process are the folks that try to do it perfectly the first time out. It's never the case. Shoot, even the master painters in our world. I just happened to be looking down at Yusra's desktop screen, and she has a beautiful, fine artwork of a gorgeously painted ballerina or some sort of dancer. Okay, and it reminded me of something that I was brought aware of when I was in art school. That a lot of times these master painters, if you look at these like Van Gogh, perfect example of this. If you look at the Van Gogh paintings underneath an X-ray microscope, you can see shadows inside the artwork where he did that painting 2 or 3 times to get it right. Okay? Classic painters often scraped off all of the paint and redid that painting because even when they were going through it, like, oh man, okay, what I did over here isn't describing that tree the way I thought it was, so I need to scrape that paint off, start over, and do it again. Okay? We have to go through the same thing. I like to remind people that we are digital artists in here. Okay? At times, we have some very mechanical tools that we have to work with, but we still have to approach all of the objects that we're creating from that artist's perspective. You've got to be open to the process. Okay? So let's start our process. Let's start exploring the shape and figure out what we need to do to generate all the information that we need to have captured for this model. Okay, so I mentioned earlier that this is going to be a symmetrical object, so I'm going to just do a simple loop slice on this bad boy. Alt-C is the keyboard shortcut. I've used an count of 1, a mode of uniform, just to put that loop right smack dab in the middle. And now that I've split my model, I'm going to select the right side of it and just delete it. I don't need it. Bye-bye. It's gone. All right. I'm also going to turn off my grid, make it a little bit easier for you guys to see what's going on. Okay. So there's my phone. Just going to work on half of it. All right. There it is. Okay. Cool. Now, before we go any too much further, I want to make sure that all of those border vertices are perfectly orientated around the center of the x-axis. So let's be good stewards of our scene. Vertex, set position. Set their position to a value of 0 along the x-axis. There we go. Now I know that I'm going to craft a perfectly symmetrical phone when I'm done. All right. So let's start to define and talk about how we can get the corners where we need them to go. Let's do this top one. Earlier, when we were overdrawing on top of the image, we drew an edge somewhere right around in here to allow the tapering of this corner to take place. Let's just go ahead and do that real fast, okay? Now, I'm in my front orthographic viewport, and I'm going to use the slice tool, okay? If I hold down the control key before I click, I'll draw out a straight line, and I'm just going to put that edge somewhere, I don't know, maybe right around in here. There we go. And now I've just laser cut my entire object, and I'm ready to go. What I'm trying to do here is to define this shape in its low resolution form. Mo polygons, mo problems, okay? We do not want to try to model the overall form with 10,000 polygons on this. Making global changes to the structure and the form of this phone will be really, really difficult if I have a lot of polygons. I only got what? 1, 2, 3, 4, 5, 6, 7. I only got 8 polygons right now. Changes to the overall shape is really easy. Okay.
What if we draw it with the pen tool?
That's fine too. Absolutely. You can do it with the pen tool.
Draw with the green font with the pen tool and bevel it and all that.
And I think that's absolutely fantastic. I really do. I think that's a great way of working, for sure. Faux show, okay? I like it a lot. All right. So I've started to define the top here. Pretty great. Some work I need to do to define this edge a little bit more carefully. But I think this is a good start. And let me show you what I'm talking about here. I need to define this radius up here at the top because it curves. Excuse me. It curves. This corner curves in. Well, if I select that edge, maybe I just run edge bevel. Yeah, that's kind of cool. Let me take a step back for a second. I want to try something here that I didn't consider a moment ago. I'm just going back. Yeah, what if I have that edge selected earlier and do an edge bevel then? This is that part of the digital jazz that I'm trying to get you guys to think about. You do something, think about how if there's a better way to accomplish the exact same goal that's going to give you a better result. Maybe I do the edge bevel now. That's a little bit better, but maybe in the wrong position. What if I change my radius type here? A little bit too big. So my initial thought and reaction was correct. I should move it first, then bevel. I'm just trying things here. We have to be open to the process of trying different techniques and different sequences. You never know what you're going to get if you don't. Now, when you're doing your edge bevel, and that's a pretty good edge bevel, okay? When you're doing these edge bevels, be very, very careful as to how many round levels you're currently using, okay? We don't want to go crazy with the round levels like this, okay? At the end of the day, this still needs to be quad polygons, okay? Having a lot of edges closely packed into each other like I have here is going to create a whole lot of technical construction issues later on down the line. If we can get away with it, let's get away with it. Maybe a round level of 1. I like that. Because these are eventually going to have to be turned into quad polygons, okay? All right, there we go. Top's looking pretty good. Let's go down to the front again, and let's work with that corner down over here, this one. I think I'm still going to use the same edge bevel, but let's test it. If I did the edge bevel as is, not so good, okay? Let's try moving it into place, kind of roughly defining those two planes. Let's see what we get now. Yeah, a little bit better. Somewhere right along in there. I'm pretty happy with that. All right, cool. Not quite done yet, so let's go ahead and add some additional loops in here, some additional edge slices to define this curvature, because what we don't have at the moment is any sort of indication as to this curve over here. We need to have some vertices in here that I can move up and down on my model, okay? So let's do it real fast. I think I'm going to use, you can use a number of tools. Slice will work. I think in this case, slice is my best guy. So I'll go grab slice, hold down the control key, left click and drag. There we go. And now I have an extra set of edges up here that I can use to define. That section of my model. Yeah. Now we're getting that curve that we want. Can probably use that same edge on the bottom, it's kind of bottom neighbor, to pull it down a little bit and match the reference. Cool. Now, if any time you want to move something, move it. See what happens when you move it. This one was a little bit low for me. What if I just move it up? Yeah, that's way better. Way better. Try things. Try different techniques. Try different placements of things. You never know what your brain is going to produce and what your brain is going to generate. Now, we've done a pretty great job of defining the overall shape of my phone from the front. Before we go too much further, let's look at what we need to do to define the overall shape of our phone from the side. The moment you add geometry in the front, and the moment you start editing geometry from the front, go ahead and start editing geometry from the side. Because remember, this is a three-dimensional model. Let's look at our geometry from the side here. And you can see that, we're doing some good things. We're getting there. We're getting there. We need to define kind of this inset here for the buttons of our phone. But most importantly, we have this mumbo jumbo up here at the top that we need to figure out. This is a problem for us. This is actually a large problem for us. So let's figure out how and what we need to do to get the result that we want. If we look carefully, really the vertices that are in question here are those 5 vertices. Okay? I need to maybe perhaps move these vertices back a touch to start defining this curve of my phone because it rounds out on the top. Let's see what happens when we start doing that. Start with these first 2. Sometimes it's just a process of going in and moving vertices and getting something and crafting something that is going to give us the result that we want. All right, so we just made a change to our model. Let's look at that change in 3D. Does that look like what it's supposed to look like? How about from the top? Ooh, no, fail, bad pat. So that didn't work. Let's hit undo a couple times and maybe revise our strategy. All right. Yeah, you can. Let's try something here. What if we grab that entire edge? This entire section, not those guys. Not these guys. These guys. We'll do the same for the back. Just grab them real quick. There we go. I don't want those guys. Sometimes when you accidentally double click, it goes a little crazy. There we go. Let's just deselect them. Don't want that one. Don't want that one. There we go. Fingers. All right. What would happen if I just did a bevel here? Yeah, now we're talking. Now this is looking the way it's kind of supposed to look. Yeah, look at that action. Yes, yes. Let's look at it from the top. Yes, perfect. Now we're talking. Okay, now we're getting somewhere. I wouldn't have discovered this unless I had made that mistake earlier, right? This is the part of experimentation instead of 3D modeling. At the core of everything that we do, we need to employ a certain healthy degree of experimentation. All right, things are looking pretty good. Now, look at my screen right now. You see this gigantic, weird, funky thing? That's a render error, okay? It's a render error. The computer doesn't know how to shade that specific polygon, and there's a reason for that. If you look at the number of vertices, shoot, let me help you guys out for a second. I'm going to go into my active meshes and do show vertices, and then I'll make them real big so you guys can see them. There we go. Look at how many vertices I have defining this polygon. I've got 1, 2, 3, 4, 5, 6. N-gon. Okay, we need to make some changes. However, and so really what we need to do is that we need to slice this thing up a little bit. Well, I could go in and maybe grab good old edge slice. I like edge slice, a fun tool. Click in the middle of this edge, drag up till it stops, and maybe do this. Okay, now I have this polygon, 1, 2, 3, 4, but this is an n-gon up here, right? So it's got 1 vertice, 2, 3, 4, 5. Okay, so to solve that again, we could use edge slice and then just go all the way down. Continuing to slice all of these objects where they need to go. Should I maybe even able to connect into that bottom one? And that's in itself not bad, but we've kind of created a small little polygon here. And we have some edge spans, these edge loops, that are incredibly close to each other. That one's close to that one, okay? And these guys in here are kind of packed in tight to each other. Let's go back to the stoplight, the martini glass, the medicine bottle, the goblets, the glasses, the subdivision objects, the subdivision surface objects that we were working with before. Okay? How did we define a sharp corner with the tab key? Edge bevel, that was the tool that we used. But what did we fundamentally need to create? Another loop. We needed to add more geometry. Okay. So to illustrate what I'm talking about. Okay. So if this red line represented the original edge, what do I need to add? You got it. A new edge on top of the original, and then a new edge below. So grand total of 3 edges. Okay. Whenever we have edges that are close to each other, like we have here, we're going to start to define a crease. Even though we have 2, not 3, it's still going to start to sharpen up. Yeah, it's still starting to sharpen up when I hit the tab key. You can see right in there, it's starting to sharpen up. Overall, it's looking pretty good, though, when I hit the tab key. Okay, not bad. But with that said, I would much rather prefer not to have these close edges in here. Let's explore the technique a little bit. Let's explore this model. Maybe what we can do is go back in time a little bit here. I'm going to hit undo. Just undo, 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 undo. And where I'm going to go, and hopefully I have enough undos. Here we go. Where I'm going to go is to the part of my model, the stage of my model before I did the edge bevel. Because really, it's this corner that's created here that turns into a little bit of an organizational nightmare when I do that edge bevel. What if I automatically sliced this n-gon first before I did the edge bevel? I might get a better structure polygonally. I'm kind of the frame of mind from my own personal technique that whenever I generate a big n-gon like this, resolve the n-gon quickly. Okay? It could come back to haunt us later on. Let's do it real fast. I'm going to use the slice command, and or I'll use edge slice, edge slice. And I'm just going to slice this corner up a little bit. Now I'm looking for ways to create quad polygons across the entirety of my mesh. So by slicing this corner going that way, I've created a quad polygon there. But this guy has 1, 2, 3, 4, 5 vertices that I need to get rid of. Well, what if I did another edge slice from this guy? I want to leave the corner alone. There we go. This is a 1, 2, 3, 4. 1, 2, 3, 4. But this one down here has 5. Well, if I keep going all the way down my mesh, let's see, I might be able to get a structure that will work. I can connect back down to that guy. How about this guy? This polygon that I have selected. Count the vertices. 1, 2, 3, 4, 5. I can resolve that by doing another edge slice along the bottom, leaving the corner guy alone. And now I have the front of my phone completely constructed through quad polygons. There we go. Now we did something to the front. We probably want to do the exact same thing to the back before we go too much further. So let's just do the back real fast. Edge slice is the name of the game here. There we go. Hold down the shift key to refire edge slice. Remember, leave those corners alone and you'll be all right. These are the types of things that I'm considering and thinking about as I go through the modeling stage. How can I best set up the foundation of my mesh so that when I do larger, more destructive operations like that bevel, I'm in a good position? Let's do that edge bevel now. See what we get. Make no guarantees. It might actually cause more problems. Have no idea. Let's go back in time and turn my reference photograph on. A little too much. Yeah, it actually caused more problems, okay? Because now I have some geometry that's close to each other, and it's just wigging out. All things that we have to think about as we go through the modeling stage of this model. Okay? Yes, sir.
Can you just select
Absolutely. So we have some work that we need to do in front of us. If you look at the structure that I've crafted here, it's kind of a disaster to a certain degree. It's not the, and really the disaster that's taking place is all of this stuff in here. If I was to subdivide this as is, yeah, there are a keyhole polygon in the mesh, and that's what we're getting. Blah. Okay. Problemo. So let's go back in time, hit undo. And let's see if maybe we go remove all of those edge spans that we so dutifully created a moment ago. And do the bevel now. Okay. When you're doing edge bevels, you got to be very, very careful to crossing like that. Okay. Be very aware. Those are cross polygons. Those are bad. Those are going to cause a lot of geometric and topology issues later on down the road. So we can't do this just kind of blindly. We have to be very, very mindful of the level of detail that we're crafting. All right. Yeah, that's really close. Hold on a sec. Yeah, I'm going to have to go back in and fix that for sure. Yep. And so I got to go back in and slice that. Okay, so edge slice, and then let's fix it. Now, there's nothing that says that we have to go straight across like that. Okay. The whole idea that I'm trying to drive home here is that we just have to look at what we're crafting and just take it one step at a time. There are no instructions for this. People, I think, they try very, very hard to make 3D modeling into step 1, step 2, step 3, and then you do this, and then you do that, and then you do this. And then on step 2482, you have a model of a cell phone, right? Well, that's not what we're doing here, right? We're not monkeys. We're not monkeys hitting a button, okay? We're not mechanical robots that are going to generate this object. We're artists. We need to go through this modeling phase and approach the modeling phase based on the information that our eyes are getting and how our experience with inside modeling, 3D modeling, tells us what to do, okay? This is an organic process. You never get it right the first time. Shoot, if I was to make this model again, I would probably do it differently. Because every experience is going to craft and determine the next ones. Let's just go ahead and just do this one on the back here real fast. I think another thing that I see people, another problem that I see people running into is that they forget to do the back, okay? And use the feedback that the computer's giving you to help make some decisions too. If you see those big rendering errors, that's usually a good indication that you have a problem. Also, every once in a while, just zip over hit the tab key. Okay, hit the tab key, see the quality of your work. Just make sure that things are solving the way they need to solve. Okay, let's turn my reference back on and take a look at how I'm doing. And I'm doing pretty good. I'm doing real well. If you look at the model from the front, yeah, not so bad. Look at the model from the side, yeah, not so bad. Are we done? No, we're not done in any sense, but this is a good start. At this stage, this is where I save. This is where I save my project file, okay? This is where I save either the first version of my project file or the second version of my project file. Because at this stage, we have a working version of the base mesh of my phone, okay? We want to have kind of an early version in its own dedicated project file that we can kind of fall back on. At this stage, everything's working, okay? Everything's working on the mesh. 2 seconds from now, I'm going to start making some new geometry for kind of the inset of this phone. I might completely screw up my model. Sometimes it's easier just to go back in time to an earlier version of your model than it is to delete things, move, hit undo a bazillion times. Save different versions of your model file. That way, you have a golden parachute just in case something happens. So let's do it. File, save as. Doesn't seem very practical, the parachute or the different versions?
Well, the fact that the parachute is golden.
That would be a barrier. Yeah, you would fall quickly. A magic parachute, let's put it that way. A magic parachute. Okay? I think I've shown you some of my own personal project files that I've used for my own work, and I think that boat that I have, that ship, the HMS Victory, I think there's like 30 some odd versions of that project file. Okay? I have a lot of different versions of the project file. The most recent version of the project is the most complete one. But just in case I need to make a big edit, I always have those others to fall back on, just in case something happens. All right. So from the front here, things are looking pretty good. We have some work that we need to accomplish here on the side. We can see that it dips in here. That's a big, big structural element. So let's define that with some edges, okay? Now, whenever we have a chamfer, whenever we have an angle that needs to jut back, we need to actually have two different edge loops to define the beginning of that angle change and the end of that angle change. I'm going to use the slice tool. You can see that I'm not using any tool that's incredibly high-tech or fancy here. I'm just using basic editing tools, basic slicing tools to set the structure where I need it to go. So I'm going to guess, just based on what I can see here, that right about in there is where I need to have the beginning of that transition take place. Let's do it again. Holding down the Control key to draw a straight line, and then I want the end of that plane change to happen right in there. Let's do the same thing for the bottom. Slice somewhere right around in there is where I want the transition to take place. Okay, I have some geometry down here already that I might be able to use to define the end of the plane change. Okay. All right. Okay, so this, in essence, is where all my buttons are going to go. All right. Because I used, let's do this. Let's look at it from the front. Yeah, there we go. Grab that guy too. Oh, hold on a second. I looked at the wrong benchmark here. Yeah, it's a button, not the beginning of the plane change. Although it does kind of curve back in there. Yeah, that's okay. We can still work with this. Yeah. Welcome to cell phones. They are kind of complex, or they can be complex. All right. So what if I grab all of these guys in here? Let's just see what happens when I just move them back a little bit. Oops, and I think I need to grab one more row. That one. And that one. Let's just see what happens when I just move and shift them back. Yeah. Now we're talking. Let's look at it from the front. Did it completely destroy it from the front? And it did. It completely destroyed it from the front. So that's not going to work for me. I need to figure out a different strategy here that will give me the result that I want. And really, the proof is in analyzing this object from a number of different angles. What we're working with here, or what we're working against, is an optical illusion. Okay? These reference images are going to take you along different directions. Okay? What you see in one photograph is going to completely change your mind and cloud your judgment on what you see in other photographs. Okay? Optical illusions are always going to be the thing we have to combat. I think I'm going to take the information that's much more prevalent in the front to define this area here for my buttons. My previous strategy didn't work, so I'm just going to delete the geometry. However, if you look down here, we already have some geometry in the right places that I could use to define what in my mind I'm seeing as kind of the lip. Okay, so kind of like this area in here, and then this edge right in there. Okay. So let's just check this out here real fast. I got some geometry here. What if I just start moving some of this around? Let's see, this one, not so useful, but these guys, what if I move that one up? That one already is in place. Cool. Cool. And what I'm trying to create here is a small little channel of polygons that I can use to describe that plane change between, because I need to have this area in here for the faceplate of the phone. It's not about creating new geometry. It's about editing the geometry that's already there. Yeah, there we go. This is pretty good. Let's move some of this out. When you're making these changes, just be very careful to move things along defined axes, okay? Don't just click and drag. That might screw it up. You know, just move things along. In my case, I'm just trying to be very, very careful and move things along the X and the Y, okay? That way I don't accidentally screw anything up along the Z. Here we go. And now I have a row of polygons that will define that corner in that plane change. Okay? It's a little kind of funky at the moment, but that's a good start. It's a really good start, actually. Now I need some additional edges up here so I can define the top. Well, let's just grab our slice tool. Okay? It's pretty cool. I like it. And what I think I'm going to do here is just move that entire row down to right about there. Now I can grab that vert, move them up, that vert, move them up. Now I'm moving them in relationship to the photograph now. And I need another slice. Let's slice it. Cool. And I think I sliced it in the wrong, nope, I didn't slice it in the wrong area. There we go. Something perhaps like that. There we go. Now what we have, let's just look at it from the front. We have a row of polygons, go do, 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 like this. To define where the buttons are going to go. Okay? Just slicing things up. Whenever we have a plane change or whenever a feature changes its direction, we need some edges there to define and outline those new features. Okay? We just got to just intelligently go through the process of looking at our model, seeing where we need to place some edges, and working accordingly. Because now, check it out. What we can do here is I can just maybe perhaps bevel these guys in. Something like that. There we go. Now this one here, not necessary. Delete it. Don't need that polygon. And if we look at our reference, yeah, now we're crafting something that is getting us closer and closer and closer to what the final thing needs to look like. You can even start making some small little detail edits here to give us what we want, the correct shading rate for some of these. Yeah, okay. Hit the tab key. We're getting there. Slowly but surely, we're getting there. Okay? This is the process that you're going to need to employ as you go through this model. The moment you add geometry, look at how that geometry affects the object from a number of different angles. Okay? I still have some decisions and some changes that I need to make to capture this change in plane. Okay? If I turn off my mesh and just look at my side reference item, yeah, it kind of curves in here where some of the buttons are. So I'm going to need to figure out how to model that. Okay? But just with some very simple geometry. Okay? Don't go crazy with the geometry. And a lot of people, what they try to do is that they try to go in, they try to make it like an 8,000 polygon cell phone initially, and then when they try to make some of the bigger features pop out, like the screen, they have a lot of different geometry to work with. Okay? Define the big stuff first. Like the screen, that's a big element. I already have a lot of geometry that I can use to define the screen. Like there's an edge, there's an edge. What if I just move some of these vertices around to continue to define the opening for the screen? I don't need to add new geometry. I just maybe need to perhaps edit the stuff that's there. Yeah, now I have some geometry in there that I could use to bevel in. Just do a bevel. Do a cool little shift there. Don't need that one. And there we go. We have the underpinning of my entire phone. Okay? Think basic structure first. Basic structure first, and then go from there. Overall structure. Hit the tab key. Now, it's going to look kind of funky in some areas, like in here, when you hit the tab key. But if we employ our basic subdivision surface or subdivision surface technique, we can very quickly shore up those edges and get the result that we want. Okay, so let's talk about how we could shore up the edges in this part of my phone to preserve this geometry, but get nicer, sharper plane changes. Help me out. What do I need to do here? Loop slice, absolutely. So let's focus our attention on this part of the mesh initially. Let's do it. Let's just do it real fast. I think I'm just going to throw in it. Now, I'm getting ahead of myself because I'm running out of time here. But trust me when I say this is something that you want to do towards the end of the modeling process. Okay? Don't go crazy with the loop slice initially. Okay? Form out, establish the basic form of your cell phone first, and then once you're happy with the basic form, okay? And when I say happy, I mean like you're done in your mind. Then start going in and adding these additional loops that are going to shore up the plane changes and define these surfaces. Because the moment we start loop slicing is the moment we go from maybe 200 polygons to 8,000 polygons, okay? It's going to logarithmically increase the number of polygons that are across the surface of our geometry. So we just have to do this at the correct stage. I always do this at the very, very end when I'm very confident that this is the shape that I want to capture. All right, let's just do it real fast so you guys have an illustration of what's going on. Now, I have my mode set to uniform. Let me set it to free. That way, when I left click and drag, I can determine where all of that stuff is placed. Okay, excellent. Let's do it on this one. Cool. Need one down there. I'll need a couple in here. Let's loop slice that guy. Then I'll need a couple down here at the bottom as well. Just left clicking and dragging in the viewport to determine the placement, and then using my eyeballs to figure out where they need to go. There it is. And then down in here we'll need a couple as well. Just hit the tab key. Yeah, and we're getting there. Things are starting to flow where we need them to flow. Okay? Very pleased. Very pleased. And then we can just keep going all the way down the mesh. Goes pretty fast if you just kind of look at what you're doing. I'll just go right there and kind of end it right there. Okay. There it is, underpinning of my entire mesh, already loop sliced and ready to go for subdivision smoothing. And it matches my reference pretty well, I think. If we were to double click the mesh, yeah, not bad. There's some things in there that I need to fix, but overall, I'm pleased with it. The biggest thing, the one that is just killing my modeling brain right now, and it's really kind of bugging me, is that these insets are just way too big. They're way, way, way too big. And that's like, they need to be a tiny little inset instead of this massive chasm on the interior of our phone. So that's something that I should go back in and change. Okay. Let's talk buttons for a second. Buttons, buttons, buttons. It's all about the buttons. Are the buttons going to be part of the base of the phone? No. Don't make the buttons part of the base of the phone. Make them discontiguous pieces. Have them bury themselves inside the geometry of the base of the phone. If you really want a Halloween nightmare, make it all one piece. Okay? I don't want you guys to have a Halloween nightmare. Have it, make it easier on yourselves this first time out. Okay? So this is what I'm talking about. Let's jump over to the front, and we got some crazy custom buttons here. So you can use the pen tool or any other tool to define the shape of the buttons. The shape of the buttons should still resemble what they, what the reference image shows you. For example, I think I'm just going to grab the pen tool and just draw away here for a second. And I'm just working, excuse me. What I'm going to do is I think I'm going to take that vertice and then round it out. And then count the number of verts that you've added. Okay, so I got 1, 2, 3, 4, 5, 6. We like even numbered n-gons because then it's very easy for us to slice this n-gon into quads when we're done. So let me go just Shift H there to get everything else out of the way. I'm going to take that vert. Don't forget, you can do vertex bevels, okay? If you increase the round level. Okay. Maybe I go grab all those, then move them where they need to be. over in there. Now, I just added a tremendous amount of geometry into my scene. That's okay. That's okay, because we're eventually just going to, let's just bevel this guy out. Or in. There we go. Well, hold on a sec. My polygon, my initial polygon was facing the wrong way. So let's flip it. Hit the F key. Hit the F key. There we go. Now when we bevel it, it should be oriented the right way. Or not. Okay, so we'll just flip everything. Now all the polygons are facing out. Let's look at it from the front. Yep, the shape is still what I like it to be. Yeah, absolutely. I think that's a great idea. Yeah, there we go. Okay, looking pretty good. Now, I would like this to be a subdivision surface if possible to round out that corner even more. So let's talk about what we can do to make this usable. Now, I have a lot of verts just chilling in this corner. There's a bunch. There's, what, 5 of them over there? I could, if I wanted to, begin to slice all these up and get it into quads. That's definitely an option for us. But sometimes, if you just select that outside polygon and then just run a bevel, just give it a little bit of an inset like this. That's all the sub-D algorithm really needs to define that shape. And then when I maybe loop slice it over here at the count of 1, yeah, there we go. That's pretty good. That's probably good enough for my button. Let's look at it. No, it completely collapsed. So I have some more work that I need to do in here. So maybe I should have made it into quads before I went any further. Okay. When you're done working with your buttons, okay, this is what I'm talking about when I say bury the buttons in your mesh. Okay. Do something like this. Okay. It's okay that they penetrate onto the inside of the mesh. Okay. If you try to cut this into the geometry, this is the nightmare. Let me illustrate the problem that you're going to have if you try to cut this into the geometry and make it all one piece. Okay? Let me illustrate this. So in many ways, I'm describing to you and encouraging you to not do this. Okay, check it out. So this is the problem that you would have here. Let's do it. I'm going to see if I can make this button part of my mesh, and I'll do it with 12 sides. Just a new cylinder, and I'm going to use this cylinder to generally define some radii. Okay, cool. Okay. Here, I'm going to cut this mesh object onto a new mesh item. That way I don't mess up the work that I'm doing. There we go. Okay, so there it is. There's my guy. Yeah, I won't try to make it kind of curves in. I won't try to make that just for brevity's sake here. I want half of it. And I'm also going to use edge slice to just get this into quad polygons quickly. I guess technically I didn't have to do this, but that's okay. And I want to use this shape as a Boolean. You guys remember good old Booleans, right? Because we can use this to extend our mesh, and we're just gonna cut this, or we're gonna just extrude this so that it penetrates all the way through my phone, just like that. There we go. And now I can use that mesh item as a cutter mesh item for this guy. All right, there it is. And now I have the loop structure that I need and the edge structure that I need for that big button. And welcome to my nightmare. Okay, this is stupid. Okay, I hate this. I hate this passionately. Okay, because now I have a lot of work in here that I have to do to get this. Oops, excuse me. To get this where I need it to go. Oh man. Okay, how am I going to do this? Bevel's going to be part of it. Let's see. I need to play the role of a mad scientist here for a second. Let's get rid of this guy. It's clouding my view. Just hide it. Okay. First things first, I need to get this all into quad polygons. Let's get rid of my... All right, easy ones. Easy victories. Okay. Well, we don't need those anymore. So what if I was to just throw on my snapping engine, do a little vertex snapping, and use the slice tool? Hello, slice tool. There we go. we go. And I know I messed up. But that's okay. There we go. All right, so there's a center line. That was the easy one. The back, I used the slice tool, so it went all the way through the back.
Yeah, but I mean, you just join two polygons.
Yeah. Oh, I don't need all these sliced in here in the back. Those can go away.
The idea is just to not do this, right?
Yeah. No. This is why you don't want to do this, because this is going to turn into a mess. Okay. This is going to turn into a mess. Now, if I was working in production and the requirements of my job demanded that I have these pieces together, this is what I'd have to go through to get it all kind of hooked in. Okay. The first thing that I'm going to do is get rid of all of these silly edges that I'm using to define the sub-D algorithm, because those are just going to get in the way. All right, let's see what we got now. Now, okay, here's what I would have to do. I basically have to get this all into quads. Okay. An edge slice is going to help me out. If I had more time, and if I wasn't using a pen tablet here, I would definitely be more accurate. But just to kind of illustrate the process, this is exactly what you'd have to do. You can see pretty quickly that you don't want to do this. Or let me rephrase that. I would recommend that you don't do this. If you want the challenge, I say do it. I'm never going to say no. I'm always willing to throw down the gauntlet and see what you guys can make. But it's going to be incredibly complex. Now, this is the work that I had to do for one button. There's like 12 of these things on the phone that I had to manage. That's a lot. And I'm not even doing this correctly because the loops aren't going all the way around the mesh, connecting back onto themselves. I'm kind of rushing through it right now just so you guys can get an illustration of the process. There it is. Hit the tab key. The shape generally conforms to what it should. And now I can, let's see, I can maybe just, bless you. I can bridge these together. There we go. Yeah, that kind of worked. Because I want a polygon. You'll see here in a minute. Set position, boom. Okay, so now I have a polygon in here. Awesome. And I can just simply bevel that in. Okay. Do another bevel. Create the small little gap for the button. And bevel it back out. Now I got me a button. Actually, let me undo that for a second. Don't want any of those guys. I do want these guys. Now I have a button. Say again? There's kind of a slice through the button. Yeah, there are. This is not perfect in any way. Yeah, I still have some major topology issues here that I need to fix, as you can see. But this is the structure, and I actually had to have another radial loop going this way. See, isn't this just so much fun? Go. And that will hold the surface a little bit more closely. Yeah. So it's a lot of work. Super advanced to get everything connected. I would not suggest you do this. Do not do this. Do not do this, okay? It's going to, only if you want to have your own personal Halloween nightmare, do this, okay? Yeah, exactly. I share your frustrations, Jonathan, because it's making my brain hurt on Thursday afternoon as well. Okay, so bury the polygons. That's totally, totally acceptable. It's used all over the place. I mean, this is not something that you don't see out there in the industry, okay? You're allowed to do this. I think oftentimes when you start looking at these online forums, definitely what's in the Luxology forums, people, the really super advanced modelers show their wireframes, right? And they show the awesomeness of their technical skill and everything's connected together. And beginners like you guys go, whoa, am I supposed to do that? No, you don't have to do that, okay? Burying the polygons, like I showed you earlier, is a perfectly acceptable way to generate the detail that you need to describe this object. Okay, this button down here is completely buried into the surface of the mesh. That's allowed. If you were to do a render, and here's my kind of, the proof's always in the render, right? If it renders correctly, you're good. If it renders correctly, you're on your way. You can kind of see what you gain by having that small little opening in there. Get a cool little inclusion of a shadow. It kind of looks like an opening, and you press the button, and the button is going to rise and fall, but that's a detail that we're not ready to, you guys are not ready to create yet. Okay? Questions? So what are you going to do first? Your backdrop items. Yeah, align the backdrop items. That's the first thing that you're going to do. After you align the backdrop items to each other, then what are you going to do? Move them away to the origin, right? Give yourself a clear, clean workspace so that your brain can understand the model that you're creating. What's next? Start modeling. Now, how are you going to start modeling? How are you going to, what shape are you? Major structure. Try to define the overall shape with as few polygons as you possibly can afford. Okay? Then what? Take it one edge loop at a time. Literally, take it one edge loop at a time. Add some geometry. See how that slice, that change in the topology affects the quality of your mesh. Make some decisions. Don't cruise through this as fast as humanly possible. Okay? And I'll just end with this kind of suggestion. This is not something you can do Wednesday of next week. Okay? This is not something that you can just cram all night on. Okay? You have to give it some time. I want you guys to dedicate yourselves to this model. You know, come in. If you can work on this model for an hour every single day over the course of the next 7 days, rock and roll. That's good. That's really, really good. It's amazing how a fresh pair of eyes and a new brain will help you figure out and decode and solve problems that you ran into the night before. I do that all the time. The moment I'm stuck on something, I go do something else for a while. Like I'll walk away from the model, and I'll come back to it with a fresh pair of eyes, a fresh brain, and I go, got it. I know what I have to do. I can see the polygons that are causing the problems. I can figure this out. Okay. 3D modeling is not something that you can cram. Okay. This is not an English paper. Although you'd never cram on an English paper. You'd never do that, right? Yeah, James and then Vincent. Yeah. Next week. You got it, next week. So just worry about the geometry this week. Next week we're going to spend the entire day talking about the textures, the materials, and most importantly the lighting that we need to employ to get a good render. No, and when I mean geometry for the Canon, I mean a couple cubes and a cylinder. Okay, have fun with it. It's supposed to be an assignment that really allows you to practice aligning all these images to each other, and then we test that alignment with some very simple geometry. At the conclusion of your lab assignment, let's just kind of go over those details real fast. Okay. At the conclusion of your lab assignment, you're going to be turning in a couple different things. Okay. I need to have your Luxology project file. Just your LXO. Don't give me the reference images. Don't submit the reference images to the Dropbox. I already have them, so I don't need another copy of them. Okay? I need your Luxology project file and a render, just a very, very quick render of your Canon, just as it's further proof that it worked. Okay, Mr. Pryor.
Do you have that image that is right there?
On
On the website, that full image.
No. Well, there you go. There's your reference. Yeah. Let's talk for a second about some of the details in the rubric of your homework this week, because I want to make sure that everyone's clear as to what the expectations for the modeling is for this. Now, this rubric is going to be the rubric that I'm going to use to grade the entirety of this project. That's why it also has the texturing, the rendering, and the creativity infused in this as well. Okay. So let's look at the modeling stuff on the rubric, because there are some things in here that I want you guys to really kind of focus on. And FYI, if you don't see the rubric, it's on the homework page, and it's in this collapsible little kind of accordion thing. Okay? All right. To get full quality on the modeling side of this project, okay? Perfect geometry that successfully captures an accurate shape of the object. No technical errors. No technical errors. That means like cross polygons, vertices that aren't rendering, flipped polygons, okay? No technical errors on the construction of the geometry. Yeah?
What about about like geometry errors, like double edges and things?
That is going to influence, yeah, we don't want any of those. Yeah, that's going to influence the render. You'll actually see geometry right on top of each other in the render, and since this is going to be a subdivision surface object, that's going to have an influence on how the algorithm smooths the shape. So we'll see that quickly, okay? So to get full credit on the model, I want clean topology. So you have to be very, 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 very aware when you're beveling things not to get crossed polygons, okay? You have to be very aware of the orientation of the polygons within the object itself, okay? So look for flipped polygons. Make sure that the surface normals for all of these objects are pointing in the right direction, okay? That's how you're going to get all the points on the model itself, okay? To completely fail this part, and you know, I'm a benevolent dictator. You know, you always get points for trying. Okay, so you always, you know, even if you do a horrible job on the model, you'll still get 2 points because, you know, I like to reward people for their effort, even if it's bad effort. Even if you, so at the very end of the scale, poor job that includes 5 or more geometric issues that results in an unsuccessful construction of the object. Little or no effort put into the model. It's very, very easy for me to spot a bad model a mile away. Okay, so make sure that, and I think this is the point that I want you guys to really walk away with today, okay, is that we're looking for clean geometry on this one. This is your opportunity to show me that you've learned something over the past 10 weeks and you can wrangle the tools and work with the geometry and create something that's clean, okay? And I'll underscore this. It's the bevel tool 9 times out of 10 that creates those cross polygons, okay? You need to start looking at your model at a vertex level, okay? We're at this point in the semester where I'm kicking the training wheels off, okay? Mama bird's pushing you out of the nest and I'm forcing you to fly. We've been doing this for 2 months now. You should be at a point in your skill where you can handle something like this, okay? Is this going to be hard? Yeah, it's going to be hard. You're going to struggle with this. It's going to be impossible, but it's a rite of passage, okay? Everyone comes out of this project feeling pretty good about their skill, okay? And don't let the guys over in the lab intimidate you on this project, okay? Because at this point in the semester, all the lab staff go, oh, it's cell phone time. Yeah, everyone's working on their cell phone. And you'll find that the lab staff kind of goes like this to a certain degree. You're on your own. Yeah, no, don't let them intimidate you. They're going to talk a lot about this project because it's a tough one, right? This is kind of the first really, really intense project that we have of the semester. The next one's going to be intense. The next one after that's going to be intense as well, okay? I dial it up. Been setting the foundation, scaffold, right? Now it's time to start doing some actual production work, okay? Questions? We've got about, 12 or 13 minutes left in class. I'll let you use this time wisely, okay? Please leverage my office hours this week as you go through this process. I know you'll use it. All right, let's get to work. Brandon, and then I'll make my rounds. Let me stop the stream real fast, Brandon.